All right, let's get right into it. We're talking about a guy named Antoine Lavoisier. Now, this is someone who basically single-handedly dragged the entire field of chemistry, kicking and screaming, into the modern age. But his story takes a tragic turn because his life was cut short by the absolute chaos of the French Revolution. It's this incredible, clash between scientific genius and pure political rage.
I mean, just think about that quote for a second. That's what one of his peers, the famous astronomer Count Lagrange, said right after he died. A moment to strike off his head, 100 years to produce another like it. So, who was this guy? And why was his death seen as such a monumental loss, maybe one of the biggest losses of the entire revolution? What did we actually lose that day?
And this timeline, it just lays it all out, doesn't it? It's so clear. You can see Lavoisier's scientific career hitting its absolute peak, right as his country is just spiraling into its most violent, chaotic period. His greatest moments and his tragic end were just on a collision course. There was no avoiding it.
So, weirdly enough, to really get this story, we have to start at the end. We need to understand the forces that brought this incredible mind to the guillotine.
Okay, so this right here, this is the key to his downfall. It's a group called the Ferme Générale. So what was it? Basically a private company that collected taxes for the king. And its members, these so-called tax farmers, were absolutely hated, despised by the public for basically gouging them. And Lavoisier, well, he wasn't just a member. The money he made from this is exactly what he used to pay for all his world-changing experiments. And, well, this was the result. May 2nd, 1794. Right at the peak of the Reign of Terror, when the paranoia was just off the charts, France's greatest scientist was executed by guillotine. He was only 51, and it was just a staggering loss. Some people at the time even argued it was a bigger blow to France than executing the king.
All right, Section 2, the man who measured everything. So now that we know how it ended, let's rewind. Let's go back and actually look at the scientific work that made him a legend in the first place. And really, it all boils down to one simple but totally revolutionary idea. This was it. His guiding principle was just meticulous measurement. You have to understand, before Lavoisier, chemistry was kind of like philosophy with some beakers thrown in. It was a lot of observation, a lot of guessing. But he insisted, no, if you really want to understand matter, you have to measure it. Everything had to be carefully weighed, measured, and recorded. And that shift from just looking at things to actually quantifying them, well, it changed absolutely everything.
And this experiment, his 101-day experiment, is a perfect example of his method in action. See, for centuries, pretty much everyone believed that if you boiled water for long enough, it would eventually turn into earth. Why? Because you'd always see this sediment, this solid stuff, appear at the bottom. But Lavoisier, he wasn't satisfied with just looking. He decided to measure. So he took a glass vessel, weighed it precisely, sealed some water inside, and then heated it for 101 straight days.
And the conclusion? It was a knockout blow. He found that the weight of that sediment was exactly equal to the weight that the glass vessel itself had lost. The earth wasn't coming from the water at all. It was the water slowly breaking down the glass. So just by doing some simple, careful measurements, he completely shattered a scientific belief that had stood for centuries.
Okay, so now let's see how he used this same principle of measurement in his biggest fight. He was about to take on the dominant chemical theory of the time, a 70-year-old idea that was frankly holding all of science back. It was like a ghost haunting chemistry.
And this was the enemy. It was called the phlogiston theory. The idea was pretty simple. On the surface, it said that anything that could burn contained this mysterious fire-like stuff called phlogiston. So when you burned a log, for example, what was left over was ash, because all the phlogiston had been released. Seemed to make sense, right? But there was one huge, glaring problem with it.
Here's the paradox that was driving everyone crazy. According to the theory, if you burn a piece of metal, it should release phlogiston, and the leftover ash, which they called calx, should weigh less. But when they actually did the experiment, the ash always weighed more than the original metal. And to explain this away, scientists started coming up with these wild ideas, like maybe phlogiston has negative weight. It was getting pretty absurd.
So, Lavoisier steps in and decides to settle this once and for all with a beautifully simple experiment. He took a piece of tin and he sealed it inside a glass vessel, and I mean completely sealed. Nothing could get in, nothing could get out. Then he heated it up, burning the tin until it turned into that white ash.
And here's the first crucial finding. While the vessel was still sealed, what was the total change in weight?
Zero, absolutely nothing. The whole system weighed exactly the same before and after. So whatever was happening, nothing was being lost. Phlogiston wasn't escape.
But then came the real aha moment. He broke the seal on the vessel, and what happened? There was a hiss as air rushed in. That sound, that single hiss, proved everything. It meant that something from the air inside the vessel had been used up during the burning, creating a little vacuum. And it was only then, after that new air rushed in, that the total weight of the whole setup finally increased. The conclusion was just undeniable. Burning has nothing to do with losing some imaginary phlogiston. It has everything to do with gaining something very real from the air. And just like that, phlogiston was dead. So, with that ghost of phlogiston finally gone, Lavoisier was free to lay down the new rules, the foundational laws that basically govern all of modern chemistry today.
And out of all these incredibly careful experiments came this fundamental principle, the law of conservation of mass. It's the idea that matter is never created or destroyed in a chemical reaction. It just changes form. Whatever you start with, you have to end with, just maybe in a different arrangement. This is the absolute bedrock of chemistry, and it all came from his obsession with weighing everything.
So, when you boil it all down, his legacy really rests on these massive pillars. First, the law of conservation of mass. Second, the modern theory of combustion. He's the guy who named oxygen, by the way. And third, he helped create the first logical, organized system for naming chemicals so everyone could be on the same page. I mean, he literally wrote the textbook on modern chemistry.
And that brings us to our final section, a republic's tragic error. We have to go back to the tragedy, because you have to ask, how could the man who figured out the fundamental rules of matter become a victim of the absolute chaos of politics?
And the irony here is just, it's heartbreaking. That job with the super unpopular Fermi General, the money he earned from that, the very same money that paid for the labs and the equipment for all these incredible discoveries, that's what put a target on his back. When the revolutionaries looked at him, they didn't see a genius scientist. They saw a hated tax collector. You know, when the guards came to arrest him, he pleaded with them, saying he was a scientist, that his work was for the good of the country. And the officer's reply was just chilling. He said, "The Republic has no need of scientists." Just think about that. That phrase has gone down in history as this perfect, awful symbol of what happens when ideology completely blinds a society to reason.
And here's the final bitter twist in this whole story. The Reign of Terror, it ended. The madness basically consumed itself just 10 weeks after it consumed Lavoisier. The very leaders who sent him to the guillotine were executed themselves. He was so close to making it through. So his whole story really leaves us with this one haunting question, doesn't it? What is the cost when a society silences its sharpest minds? Lavoisier's death wasn't just a loss for France. It was a loss for all of us, for humanity. It's just this stark, timeless reminder of the terrible price we pay when we let politics and blind passion extinguish the light of reason and knowledge.